Hari Om. In the operating system course, we are currently discussing the topics in module 1. As already told, we had already discussed all these topics up to user and operating system interface we discussed in our last session. We are talking about the details or the concepts of operating system structures, in which the operating system is viewed from the point of services provided, interfaces, components and their interconnections. We had seen what are the different operating services, system services available. Then we also talked about the two approaches for the interface, command line interface and the graphical user interface. We had seen what is a graphical user interface also. So the choice of whether to use a command line interface or a graphical user interface is mostly one of personal preference. So if you see the Linux system administrator, they will mostly use the command line interface, right? So the power of Linux operating system lies in the command line mode. So most of the system administrators will be using the command line interface. And not only that, the power users who have deep knowledge of the system, they will also be using the command line interface. So rather than using a graphical user interface in the kind of operating system like Unix and Linux operating system, the power lies completely in the command interpreter and the command mode, or you call it as command line interface. So any system administrator or the users who wants to get the full potential of the operating system, they will make use of the command line interface. The next very important operating system structure is the system calls. So system calls are the one which provide an interface to the services made available by the operating system. We had already seen where exactly the system calls lie in the operating system view. You can see here the user and operating system, sorry, the user and the different system or the utility programs will be accessed using the graphical user interface or the command line interface or provided by the operating system. And whatever execution statements that you have in a user program and system program will get the services of the operating system through this system call. So we should also understand what exactly a system call is. So system calls are nothing but a kind of interface which provide the operating system services for the user program. So generally these system calls will be written in high level languages like C or C++, and some of the low level tasks are using assembly language for the instructions. Sorry. Most of the system calls are written in high level language like C or C++, and some low level tasks are using assembly language instructions, right? So all the system calls will be in the form of instruction. It will be in the form of instruction. We will be seeing an example. It will be in the form of an instruction, or I can put it this way, it will be in the form of a function, as you have read function or you write some display function generally, right? So you will have display open close parenthesis. All the system calls will have this particular format, the function name and open close parenthesis. Let us take an example to illustrate how the system calls are used by the operating system while executing a program. Let us take this example, a program which read the data from one file and copy that data to another file. So it's a simple copy program, right? What you had already experienced in your C programming language. You might have written a file copy program in C in the file handling concept or in the file handling section. What do you do generally? You will ask the user to enter two names of the you will ask the user to enter names of two different files, the source file as well as the destination file. Then what do? You open the input file and then you create the output file also. Then you will have a loop to read from the input file and write to the output file. Then after the entire file is copied, what you will have? You will have instructions to close both the files and then you terminate the program normally. So this is an algorithm, I should say, or the kind of program instructions that you will have in any high level language program to copy a file. Okay. Now in this case, when you ask the user to input names of two different files, what are the things you have to do? You need to prompt the user, enter the first file name, or you will say enter the source file name. That prompt must be displayed on the monitor, right? So when it is displayed on the monitor, obviously it has to deal with the input output operation, correct? In the same way, again you will ask the user to enter the destination file name. By the time again you have to invoke the input output operation. So input output operation is one of the services that are provided by the operating system, right? Input output operations are one of the services that are provided by the operating system. So if this is the case, obviously when you have prompt, you will say printf, you will have a printf function, and in the printf function you will say enter the source file name. Then you will have the scanf function. Then you will have again another printf function, enter the destination file name. Then you will have a scanf function, right? So both the scanf and printf for reading the names of two files needs the input output operation service. Now how will you get the service? I need to use a system call. Then you need to open the input file. So whenever it is opening the input file, it is completely the file system management, right? Again, let me go back to the image. Here, file system management, right? So we had already seen file system manipulation is one of the services provided by the operating system. Obviously, so this service is to be requested by the program, by your C program, what you have written here for copying a file. Then for opening that input file, the system calls that are used for the file manipulation is to be invoked. Or if you want to create the output file, or if you want to read from the input file, again reading is some input output operations, right? Then you need to close the files. That is also again dealing with the file manipulation, right? Then terminating normally, program execution. We had seen program execution is one of the services of the operating system. So in that it will start your program, it will terminate your program, all these services will be provided. So for terminating again, you need the support of the system call, right? So now you can understand for a program which, say this is a C program, let us assume this is a C program. So for a C program, something like this, you need to have the system calls to invoke the services that are provided by the operating system. So this is how the system call sequence happen. The system call sequence for the above program is shown in this particular figure. You have the source file, you have the destination file. You want to copy the content of the source file into the destination file. So what you have to do? You have to acquire the input file name. So some prompt is to be written onto the screen. then get the input from the user. So this is dealing with the system calls for input output operations. Again, you have to acquire the output file name, that is the destination file name. So you will have a printf, like in your C program you will say enter the destination file name, that is what you call as write prompt to the screen. Then you get the file name from the user. Okay, so once you get the source file name and the destination file name, you need to open the input file. When you open the input file, automatically the operating system has to check whether the file exists or not. So if the file does not exist, you try to open a file which does not exist, so obviously the system call will give you an error and it will terminate the program, abort the program. In the same way, you need to create the output file. If the file is already existing, it will terminate the program. Or sometimes in some operating system, what it will do, if the file already exists, it will overwrite the file. Or some operating system, what it will do, if the file already existing, it will ask the user the confirmation whether you want to overwrite it or not. So it is up to the design and implementation of the operating system. Then you will have the loop, again reading from the input file, writing to the output file, needs the help of system calls to get the services of the operating system. Then closing the output file, again this is another system call. So for doing all these things, writing, accepting the input, writing, accepting the input, opening the input file, creating the output file, then reading from the input file, writing to the output file, then closing the output file, terminating normally. So all these things need the support of system call, using which you get the services of the operating system. So even simple programs, so this is a very simple program, even simple programs will take heavy use of the operating system, because frequently the systems execute thousands of system calls per second. So just for one simple C program, this many number of system calls are used. So imagine if you have a larger application in your operating system, if you have thousands of processes running as a background process, then for all these things a heavy load of system calls will be executed again and again in an operating system. So this is another simple C library which invokes the system call. Say for example, if you have a C program like this, you will have a printf function. Now this printf function is available in the standard C library. Once it gets the standard C library, up to this part, right? So it knows where the printf function is available. It is available in the standard C library. It will be invoked. Up to this part, it will be the user mode of the operating system. When the printf function is converted into a system call, when the printf function is converted into a system call, or I should say transformed into a system call, by the time it enters into the kernel mode. We had already seen whenever an user application program is running, it comes under user mode. When the computer system executes the operating system instructions, then it comes under the kernel mode. So when the printf function is transformed into a system call function, then automatically it will enter into the kernel mode. So this is how the system call functions. Whenever you have any input output operation, it goes into the kernel mode and the corresponding system calls will be used for getting the services. It may be a program execution service, it may be a communication service, it may be an input output operation service, it may be file manipulation service. For all these services, we have system calls which will be invoking the service of the operating system. So this is another diagrammatic representation. The user process will be executed Whenever you have functions like printf or scanf, automatically the user process will be calling the system call. When it calls the system call, the mode, execution mode will be switching from the user mode to kernel mode, and the mode bit will be changed. All these points we had already discussed. Or kernel mode and user mode like change or mode bit use same we had already discussed in our discussion, earlier discussion. So the mode bit will be changed to 0 so that it enters into the kernel mode, and the system call will be executed, and then before returning it changes the mode bit to 1 so that it comes back to the user mode for executing the user process, right? So this is a simple depiction of how a simple user process switches from the user mode to kernel mode. Now, when you take these system calls, the system calls are mostly accessed by programs using application program interface rather than direct system call use. So, no system calls are directly used in your program, right? You don't use system call directly. The user program will not have the system calls directly. It will be using APIs. So, I can say printf is one of the API, I can say, right? Or I can say reading from the input file, writing to the output file using your high level language functions are known as APIs. So system calls are not directly used in your program. Instead, we use application programming interface. And the functions that are included in the application programming interface will invoke the actual system call. So by using the application programming interface, the benefits are, one is portability, the other one is ease of use, right? So if you are asked to write a program using system calls, it will be very difficult for you to have the flexibility. So instead of that, what we do, we are going to write the program using APIs, and these APIs will indirectly call the system call functions. Okay, so these are the two benefits we can say by using the API. And the application developers, right? So when you are writing a C program, when you are writing a Java program, or when you are writing a Python program, the application developers will design the programs according to an application programming interface. So whatever APIs are available, those APIs you are going to use in your program, and these APIs will indirectly call the system call function. So these are the common APIs available, like you have Java API, POSIX API, or you have Win32 API. These are some of the APIs which will be used in your application program interface. Say for example, this is one of the standard API reading a file. Using Win32 API, you have a function like this, read file, and this read file will have this many number of parameters, like what is the file to be read, when you are reading the file, where will you use the buffer, and how many number of bytes to be read into the buffer at a time, and how many number of bytes read during the last read, and also it indicates whether it can be overlapped or not. So all these parameters will also be used in the read file. For example, when you are writing an application program, right, imagine you are writing an application program to read a Word document, right, to read a Word document. So by the time what you do, the program will make use of an API called read file, and it will pass all these information to get the file read. And not only that, even this API will also have another function defined in a library. Now printf nu പറഞ്ഞിട്ടുള്ള ഒരു library ഒരു function മാതിരി, you will have some functions to invoke this API also. Now you will have application program which will be invoking the APIs, and from API it invokes the system call, and the system call get the service of the operating system. That is how it goes. Your application program, then from the application program it goes to the API, from API it goes to the system call, and from the system call it gets the hardware service. Okay, so that is how it goes. So that is it about what do you mean by system call. So if you are asked to write what do you mean by system call, all these points you can write. Then these are the different types of system calls. The system calls for process control, file manipulation, device manipulation, information maintenance, communication and protection. So if you see here, in the process control you have system calls for loading a process, executing a process, creating a process, terminating a process, getting the attributes of a particular process, right, or setting the attributes of a particular process. Like process attribute can be what is the process ID, what is the process name, who owns that particular process, who initiated the process, and what are the file permissions available for that particular process. We call it as the process attributes. Okay. And you have a system call to end or terminate a process or to abort a process in between. You can have a process, a system call for waiting, to wait for another process to get terminated, or you have system calls for allocating and freeing the memory used by that particular process. So these are all used under process control. The same way for file management, you have system calls for creating a file, opening a file, closing a file, deleting a file, reading, writing and reposition, right? Suppose if you want to rewind that particular file, or you want to place the file pointer in different locations, right? And getting the file attributes or setting the file attributes. Again, file attributes means what do you mean by a file ID, file pointer, file name, then who owns that particular file, what is the file permission. That is what you call as file attributes. Then you have device management, obviously requesting for a device, a system call for releasing the device. If you want to print something on the printer, then obviously the user will request for the printer device. So you need a system call to request the printer. The same way, once you have completed printing, you have to release that particular printer. So for releasing, again you have another system call. So these are some of the device management system calls. Then information maintenance. These are some of the information maintenance system calls, like getting the process information, getting the file information, getting the device information. The same way, setting the process information, setting the file information, then setting the device information, or the date and time of the system, or the system data, like what is the processor, how much memory is free, or what is the execution speed, or you want to know the free location of a particular primary memory, right? And so those kind of information is what you call as system data. How many processes are currently running, right? You might have studied PS command in Linux administration. So it shows what are the currently running process available in the system. So these are all the information maintenance. And communication, obviously for the inter-process communication and inter-process synchronization. You have shared memory as well as you have message passing. You can send a message, receive a message. You can transfer the status information, right? Whether a particular process is in the running state or whether the particular process is in a wait state. So that particular status information can also be shared. That is all coming under communication system calls, right? So these are the different types of system calls available. Now apart from that, we have another very important topic is the operating system design and implementation. Now, if you take the operating system design and implementation, there are some of the challenges that are to be faced in designing and implementing an operating system. Imagine you want to design an operating system and you want to implement that particular design, right? The three very important challenges you will be facing is how to set the goals for your operating system, what are the different mechanisms and policies that you are going to use, and the implementation, how you are going to implement the design goals, right? So these are the three very important challenges you will be facing in designing and implementing an operating system. If you take these problems or challenges, there is no complete solution to these kind of challenges, right? But there are some approaches which prove that it is successful in solving these problems. Let us see what are the solution. Talking about the design goal challenge, it starts by defining the goals and specifications for an operating system. Imagine your software engineering concept, right? So recollect all the software engineering concepts. In the software engineering concepts, what you do? Based on the objective of the system, you will collect the requirements, then you will go for designing the software, then you will go for implementing the design, then you go for testing and maintenance, right? Now, before you collect the requirements, you will have one objective set for that particular software. So since operating system is also a software, so before you start with the operating system, you need to set the goal, you need to define the goal, like what for you are designing this operating system, and whether this system is a time sharing system or a real time system or a multi-user system, or is it an embedded system kind of thing, whether this operating system is used in a server machine, or is it used in a laptop, or is it used in a tab, or is it to be used in a mobile phone, that should be decided. So the defining the goals and giving the specification is completely based on what device you want to use this operating system, and what type of operating system you want to have, whether you want to have batch processing system, you want to have time sharing system, multi-user operating system. So based on that, the goals are to be defined. Now, whenever you define this particular goal, the requirements of an operating system will be divided into user goals and system goals. So, from the point of the user, how you are going to use that particular operating system, then from the point of the system, computer system, again you have to set the goals. So user goals, operating system should be convenient to use, it is easy to learn, it is reliable, it is safe, it is fast. These are some of the design goals. Whereas system goals, operating system should be easy to design, implement and maintain, and it is very flexible, it is reliable, it is error free, and it is very efficient. So these are some of the system goals that you are going to have for the operating system. Then the second important concept or challenge is mechanisms and policies. So defining the mechanisms and policies. Now policy is nothing but what will be done, whereas mechanism is how we are going to do that. Policy is what is to be done, mechanism is how is to be done. Say for example, if two users are requesting access to a file, to a same file, right? Same file they are requesting. So simultaneous request is coming for the file access. Then the operating system must have a policy to decide to which user you are going to give the file access. So it may be based on the priority, or it may be based on first come first serve, right? Or it may be based on whether it is a user process or a kernel process. Like how you are going to decide the simultaneous request which is to be served by the operating system. So that is what you call as policy. You need to decide, right? Now mechanism is nothing but deciding how to give access to the file for the selected user. So here you decide, the policy will say this is the thing you can decide based on the priority. അങ്ങനെ പറഞ്ഞിട്ട് പോളിസി ഇതിൽ പറയും. അപ്പോൾ based on the priority പറഞ്ഞിട്ടുണ്ടെങ്കിൽ how will you get the priority information? Once you get the priority information, how you are going to give access to that particular file. So that is all coming under the mechanism. So the separation of policy from mechanism is a very very important principle that is coming in the operating system design and implementation. This is one of the very very important challenge that you will be facing, and it allows maximum flexibility if policy decisions are to be changed later. So the policy decisions are very important for the resource allocation also. So whenever it is necessary to decide whether or not to allocate a resource, policy decision must be made, right? So whether to allocate a resource for this particular user or not to allocate the resource for this particular user, that will be done by the policy decision. So whenever the question is how, then it is the mechanism. How the decision is made. What decision is to be made is done by the, or let me say, whether to allocate a resource or not is done by policy decision. Once you have decided how you are going to allocate the resource. So that is the mechanism, right? I repeat, whenever there is a simultaneous request coming in, the policy will decide to whom the resource is allocated. Whereas once the decision is taken, how the resource is allocated will be done by the mechanism. Then once the operating system is designed, the design must be implemented as an operating system. So early operating systems are completely written in assembly languages. Even though nowadays we use high level languages, some operating systems are still written in assembly languages itself. But mostly operating systems nowadays, especially the operating systems, are written in higher level languages like C or C++. And the advantages of using high level languages, the code can be written faster and it is more compact also. It is very easy for you, right? Comparing to an assembly language program, if you write it in high level language, it becomes more compact and it is very easy to understand. And not only that, you can easily debug it also, and it is easier to port it. You can move from one hardware to another hardware, right? So to different platforms also you can port it. So you can run a Linux operating system in an AMD machine, or you can run it in a Intel machine. Whichever hardware you are going to have, you can run in that particular platform. Whereas the disadvantages is reduced speed, right? The execution may be little slower comparing to assembly level language program. And increased storage requirement. So you need increased storage requirement for the operating system. So if you are going to write it in assembly language, say it may take only 100 MB. Whereas if you write the same using C or C++, it will take more than 100 MB, right? So these are the advantages and disadvantages of implementing an operating system in high level languages. Okay, so with that we are completing the first module. So in the first module we talked about the operating system structure and operations very briefly. Then the 4 major functions of an operating system we had discussed. Then we had also seen in the operating system structure the different services and the different kinds of interfaces, different types of system calls, and the challenges that are available in the design and implementation of an operating system, right? So with that we complete the first module. We will be discussing module 2, which is going to be very interesting, the process management. So the different mechanisms or the different algorithms that are used for job scheduling, CPU scheduling, etc. will be discussed in the second module. Okay, with that we complete the first module. Thank you.